Yeah. All right, here we go. Section 5.5. I've got 3 lines up here. The reason I put the listen now. The reason I put these little grid marks, these little graph marks there, was just to show you that the lengths of these things. That's about the only way I could do this. So anyway, this is 1, 2, 3. Did I count right? 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12, 13. Yep. So this one's 6, this one's 9, this one's 13. So what our first theorem, yep, it's a theorem, says is this, that you can't just make a triangle out of any sides that you want to. They have to be certain lengths. All right, and a lot of people don't think that. They can think, oh, I could take any 3 lengths and make a triangle out of it. Well, let's think of this. What if I had a length like this, and let me think, a length like this, and a length like that. All right, with those 3 lengths right there, can I form a triangle out of that? Because watch, if I went like this, I could put that right there, couldn't I? I could take this, and I could put it right there. And you say, yeah, but I could tilt this a little bit different so it makes a triangle. Well, really, could I? Let's do this. Let's click on this. What if I wanted to... Watch. Could you? Well, to make a triangle with these 3 lengths, though, the vertices have to hit. Look, I can make that really, really skinny. Is there any way that that will ever reach there? No matter how skinny I make that, no matter how far I tilt it over. Is there any way at all? No, there's really no way at all. So with those 3 lengths, can I make a triangle out of those 3 lengths? No. I mean, is this what you were saying, Ricky? Do this?
Yeah.
Like this? Yeah, but then I haven't made a triangle out of those 3 lengths. But then it's not that length. You're not getting my point, okay? My point is you have to use those 3 lengths. I'm not saying just these 3 little lines right here and then just cut stuff off. I'm talking about the lengths of these. You got to take that whole entire length has got to be one side of the triangle. This whole entire length has to be another side, and this entire length right here has to be a third side. Is there any way to get those 3 lengths to become a triangle? Is there? No, there's no way you can do that. So I can't just take any 3 lengths at all to make a triangle out of that. All right, so what has to happen? Well, I've got one right here. So this black one is 6, the red one is 9, and the green one is 13. You want to hit the light just so you can see the colors a little bit better? Does that stand out a little bit better? Okay, that's red. What's that? First one's black. How's that? Is that better?
Blue, red, green.
That would be black. It's absolutely black, yes. Okay? I'm telling you, it's black, okay? Y'all are colorblind. Okay, so watch. So, okay, hush. Let's listen. Come on. We don't need all that silliness. Look. What does stop mean to you? I guess it means keep talking. That's not what it means to me, though. So let's pay attention. Got that on video, Chandler Swan. Okay, so... So watch, I got 6 and 9 and 13. Now I can have a triangle out of that because watch, let's take the 13 first and just move it over here. Just have to remember the green one is 13, okay? And we'll take the red one. Now we're going to have to tilt it a little bit, right? So, I don't know, let's tilt it like this, let's say. And I wish this program I could just take one end and just kind of drop it down. It would kind of anchor itself right here, but I don't think I can do that with this, but I'll do it the best I can. Okay, and let's just tilt that about like that. Now, I could probably play around with this so that they meet. Would you agree?
Yeah.
Alright, so I'd probably have to, it might take me a little while, but maybe tilt that a little bit more. See what I mean? It'd be nice if it anchored itself down the bottom, but when I rotate it, it just does that. Yeah, that's what I'll do. I'll run out and get that. It's not? Well, you buy it for me for Christmas and I'll use it, okay? Sure. Anyway, that's pretty close, isn't it? So would you agree that that does make a triangle?
Yeah.
Yeah, absolutely, okay? So what has to be true? Look at the lengths. The shortest one was 6, the middle one was 9, and the longest one was 13. Well, according to this theorem, and they call this the triangle inequality theorem. Let's write that down. Triangle inequality theorem. Alright, according to this theorem, it basically says this, that any two sides, if I add up any two sides of my triangle, it has to be larger than the third side. So let's just take a look and see if that works with all the situations. I could take any two sides of my triangle. When I add them up, it has to be bigger than the third side. So which ones do we want to add up first? 6 plus 9? What's 6 plus 9? It's 15. Is 15 greater than the third side? Yeah. Okay, so it is greater than 13. So that means, so far anyway, we can have a triangle. Let's add up a couple other combinations. Let's go 9 and 13. So what's 9 and 13? That's 22. Now, 22 has to be greater than what? The third side, which is 6. Well, that's pretty obvious, isn't it? And then what else do I have? I got 6 and 13. So 6 and 13 is what? 19. And 6 and 13 have to be bigger than what? 9. And is it bigger than 9? Yeah, absolutely. So if all three of those work, then you can have a triangle. So what they're going to do is they're going to give you a section of problems. They're going to give you sides. They're going to give you certain sides of a triangle. They might not even have a picture of it. They'll just give you, one side is 6, one is 9, one is 13, and you have to tell whether or not you can make a triangle out of those three sides. Does that make sense? Now look, I went through 3 different possibilities, but really, I could kind of narrow this down instead of going through all 3. Because look, if I take the longest side and add it to any of those other sides, don't you think it's going to be bigger, okay, than the third side? Yeah, if I start with the longest side. So really, what's our true test? Take what? Take the 2 smaller sides, right. Take the 2 smaller sides. So you don't have to go through this and this when you're testing to see if it's going to be a triangle or not. Just take the 2 smaller sides, 6 and 9. If that comes out to be bigger than 13, we're good to go. We're allowed to have that. All right? So watch. This one, this red one, which is 9, this black one, which is 6, it has to be bigger than this right here. Because what if it wasn't bigger? It wouldn't reach. Exactly. That's a good way to put it. So watch. I got to figure out how to do this. Maybe not that way. I guess I have to do that rotate thing again. Try this. Okay. So watch. What if I made it so that angle is like really, really skinny? Actually, that's what I wanted. I actually wanted to do what I was going to do earlier. Let's make that shorter, and let's make this a little bit shorter. Okay, like that. Okay? So watch. Here's my lengths now. I could tilt this as skinny as I possibly could, but if these 2 lengths, if I took these 2 lengths and added them together, there's no way it's going to be bigger than this green one, is it? All right? Do you see that? So then I couldn't have a triangle out of it. So that's basically why you can't have a triangle. Let's do this though. Let's say, let's go back to what we had, if I can do that. Okay, there we go. Tell you what, let's get these out of the way. Watch this. What if I had a line segment, starts right here, and I'll show you what I'm going to do here in a second. Boom, and then right there. Okay, I've got actually 2 different line segments. I know it doesn't look like it, but there's one and there's another one. You see that? What if these 2 actually equaled the third side? So what if this and this, what if this was like, instead of 6, what if it was 4? Could I have a triangle with sides 4, 9, and 13? Okay. Now, I don't know if this is 4 or not, but let's just pretend. Oh, you know what we could do? The way I started this thing off, we could do this. So 1, 2, 3, 4. Let's actually make this. We'll put this so it lines up so we can count over. Alright, so that's 4. 1, 2, 3, 4, right? And then this, we'll just put it up here. Make it easier to see. And this is 9. Is it? Somebody count for me. Let's make it hit right on. Okay. That's pretty close. That's close enough. Okay. So watch. If this is 9 and this is 4, guess what? If I take this and if I was to rotate it even just a little bit, is there any way that these are going to form a triangle? No, there's not. Okay, because watch. If I take it and put it right here, I'm always going to have a gap. Actually, I can even tilt it up. Let's see. Did I do that right? This is the first time I've tried this with this. Usually I just use my markers and show it by my markers, and I thought, oh, this would be a cool way to do it. But I'm trying, so just be patient with me here. Yeah, I think I made that a little bit too long, didn't I? That should be right there. Okay, that's 4, right? 1, 2, 3, 4. And that was 9. So you're going to see that there's no way that if I took this and I put it right on, okay, that's pretty horizontal. Yeah. See, watch. The only way that these two are going to touch is if they're what? They're completely flat. Do you see it? See right there and right there? It's the only way they're going to touch. But do you make a triangle out of that? No. You've got like 0-degree angles here, don't you? Right? There is a green one underneath of there. But there's no way you can make a triangle out of that. So the two smaller ones, even if the two smaller ones equal the longer one, there's no way I'm going to get a triangle. Make sense? So what has to be true about the two smaller ones? They have to add up to be what? Larger than that third side. Okay, so this has to be larger. I should say the sum of these two have to be larger than that green one just to make it a triangle to begin with. Well, let's think about this. Let's think about what's the smallest, what's our range of possible lengths for these sides right here. What I'm saying is this. If, that's not how I want to say it. How do I want to say it? It says, right. I just want to see how they word it because I'm not wording it very well. It says find the range for the measures of the third side of a triangle given the measures of the two sides. Okay, so watch. Let's pull this one out and say we have this one right here. We'll still use the same numbers. All right. So I'm given these two measures right here. This is 9 and this one is 4. So now the third side. If I'm going to make a triangle out of this, so if I'm going to take this and make a triangle out of it. Right, I'm going to have to tilt this up a little bit, right? I'll probably have to, if I can move it, if I can grab this thing, tilt this a little bit. What's the length of that third side going to have to be? Well, think about it. So watch, if I went to there, you see that? That third side right there, what's it going to have to be? It's going to have to be bigger than what? It's got to be bigger than 13, doesn't it? Let's see. So 9 and 4, if we put those together, that would be 13. Actually, it would be less than 13 because the largest it could possibly be. If I put these right up next to each other, if I put them completely flat, that would be 13, wouldn't it? Yeah. As soon as I tilt it, what's happening to that third side? I'll do this in green. It gets smaller, exactly right. So watch. As soon as I, if I connect it from here to here, guess what just happened to that green side right there? If it was 13 when it was completely flat, if I tilted those two sides up a little bit, what happens to that side? It gets what? It gets smaller, doesn't it?